So here we go with question 3. It's quite a beast of a question, but it starts off nice and simply, asking for a definition of the force constant of a spring. So just get my pen out. If we know that the force is proportional to the extension and the constant of proportionality is k, so that's the force constant, so I can go F over x is equal to k, so that tells me that the force constant is defined as being the force required to extend the object by unit length, so force per unit extension. And let's move it on to part B, and the first part of part B. So we've got this trolley, and it's stretched between two springs, spring A and spring B, and they're held in support, so like that. The trolley is on a horizontal table, it's at rest, and these two springs A and B are identical. And we've got to draw an arrow on figure 3.1 to show the direction of the force exerted by spring A on the trolley. Label this with an arrow F. Well, what's going to be happening is it is going to be trying to pull it over to the left. And here we go now, part 2, which is also in a couple of parts. And it's telling us the trolley is 0.8 kilograms. The force constant for each spring is 14 newtons per metre, and a student pulls the trolley to the left as shown, so they've just shoved it this way a little way. The extension of spring A is 0.3 metres, and the extension of spring B is 0.5 metres. And the student releases the trolley, and we've got to calculate the initial values of the acceleration of the trolley. So the acceleration when we've got these two extensions. So what we need to do, if I just try and explain that. So what we've got effectively is we've got A pulling it in this direction, and B, because it's extended more, will be pulling it in this direction but with a greater magnitude, and we need to find out what those are. So we know that the force is equal to kx, so let's put the numbers in here. So the force is equal to the force constant, which is 14, and we're multiplying that by 0.3, and that will give us a magnitude of 4.2 newtons. And the same over here, we've got F equals kx, and again this is going now on force B is 14 multiplied by 0.5, and that's going to equal that's going to be 7.0 newtons. Therefore we know we've got a mass of 0.8 kilograms, and we know that F is equal to ma, and our resultant force F will be 7 minus 4.2, and that's going to equal 0.8 times A. If I rearrange that for A is going to equal 7 minus 4.2 all over the mass of 0.8, and when we stick that onto our calculators we get an initial acceleration of 3.5 meters per second squared. Now let's move on to the second part of this. I've put the diagram in again for us. So now what we've got to do is work out the ratio of the elastic potential energy for spring B over the elastic potential energy for spring A. Now the elastic potential energy, let's call that E, is going to equal 1/2 kx squared. Excuse me. Now, because this is a ratio of the two, effectively what I'm going to be doing is I'm going to be going 1/2 k x of b squared over a half k and the extension of a squared. And what we'll notice is these halves cancel out, that k cancels out, and that just leaves us with this ratio, which is going to be the squares of the extensions. So if we go back and find out what those extensions are, the extension of A is 0.3 meters and B is 0.5. So if we stick those in, that gives me 0.5 squared over 0.3 squared, and that comes out as being in a ratio of 2.8. Now let's move on. We've now got to explain why the acceleration of the trolley decreases as it travels a small distance to the right. Okay, so if we go back, let's just have a look at our diagram. We've got, the reason it's said a small distance is because as this trolley moves over to the right, through the equilibrium position, it will change. So it's just asking us what's going to happen to the acceleration just as it moves a little bit. Okay, so what is going to happen is, the acceleration decreases because, and that's always a good word to put in an explanation, the resultant force. Decreases, and let's just see why that is. So again, if we go back to our diagram, basically what's happening is now A has extended more, so the force on A which is in this direction, remember, has got bigger, and B is now extended less, so that means the force in this direction has got smaller. So when we when we add those two forces together, the resultant force of the two will be smaller than in the initial case where A is small and B would be even larger. Now, just for the last part, I think this one's quite easy. We have to say, state and explain how the acceleration in your answer to II part 1 would be different when a heavy object is fixed to the trolley. So what I would do is I would state it first. I would state that the acceleration would be less, and because now we've got to explain, I would explain that by saying because the acceleration is equal to the force over the mass, a greater mass leads to a smaller acceleration. There we go. Quite a long question, but some easier bits, some harder bits. But on the whole, I don't think it was too bad.